The RS rheometer is Brookfield Engineering's powerful instrument for measuring viscosity in either controlled rate or controlled stress mode, and for measuring yield stress, modulus, and creep. One of the more popular RS instruments is the RS-CPS cone plate system. One of the challenges when using this instrument is setting the proper gap based on the cone you will be using. This video will address this and show the correct method for gap setting using the RS-CPS. The cone you ordered with your instrument will come with a data sheet. This data sheet will state the cone number, measuring system, shear rate and shear stress factor, and the cone truncation in millimeters. The cone truncation takes into account the tip of the cone being removed to avoid contact and friction with the bottom plate. We will use the cone truncation value to set the correct gap. First, line up the zero on the micrometer ring with the zero mark on the scale on the column. Turning the micrometer ring clockwise moves the instrument head in a downward direction. Counterclockwise moves the instrument head in an upward direction. Once the zeros are lined up, turn the micrometer ring left, clockwise, one complete revolution. Then turn counterclockwise, one complete revolution, back to zero. This prevents backlash of the threads from influencing the accuracy of the zero setting. Insert the cone by pushing the coupling sleeve up. Insert the cone in the coupling and push the sleeve down until the measuring element is held tight by the coupling. Loosen the hexagon screw on the measuring system to allow the cone and cone shaft to move freely. Lower the instrument head. This will compress the element. Set the reading on the measurement dial to 0. Tighten the hexagon screw, which will lock the measuring element in this position. Lift the instrument head and lower it again. The reading on the measurement dial should read 0 again. If the measurement dial does not read 0, repeat the procedure. Raise the instrument head. Set the gap according to the cone truncation value on your data sheet. For this example, we will use 0.0497 millimeters gap setting. The red M on the micrometer ring indicates 0.050 millimeters. So the micrometer ring should be set almost to the mark associated with the red M, and lower it again. The correct gap is now set and you are ready to run a calibration. A calibration fluid for the RS-CPS is selected based on the geometry you will be using. We will use an RC50-1 cone spindle and B10200 fluid for calibration. You will need to check the calibration at 3 torque settings of 250, 500, and 750 per mil. The measured viscosity of the fluid should be between 3 to 5% of the actual value. In this case, the actual value of the fluid is 10,170 centipoise at 25 degrees Celsius. For the RC50-1 cone, you will need to use 1 milliliter of fluid. Place the sample in the center of the plate and bring the cone spindle down. Make sure that the fluid can be seen around the entire circumference of the cone spindle to ensure that the gap is fully flooded. Remove excess fluid if necessary with the police tool. Sample volume is approximate as this varies with the cone truncation and angle. This is why excess material needs to be removed with the police tool. Set the temperature controller for 25 degrees Celsius and allow adequate time for the cone and fluid to come to equilibration. About 10 to 15 minutes should suffice. The viscosity standards are very sensitive to temperature. The temperature of the viscosity standard should be controlled at 25.0 degrees centigrade, plus or minus 0.2 degrees centigrade. To read the viscosity, select Run Single from the main menu. Select the appropriate measuring system, in this case RC50-1. The input value screen will come up. The first choice is M per mil to set the torque value. Now, input 250. This is the first torque setting. Then the number of measuring points by setting MP to 1, and set the time to 120 seconds. At this point, you can input the ID. This is to identify the sample if need be. Now press OK. Press ST to start. Allow the program to execute and record the viscosity value on the display at the end of the test. Make sure the viscosity value is within 3 to 5% of the actual value of the fluid. Consider the 3% window. In this case, 3% of 10,170 centipoise is 305 centipoise. So the acceptable window is 9,865 centipoise to 10,475 centipoise. If this reads correctly, repeat this procedure with torque settings M per mil of 500 and 750. If the viscosity values at 500 and 750 are within 3 to 5%, then the instrument is within calibration. The RS displays viscosity in Pascal seconds, not centipoise. To convert this reading to centipoise, keep in mind 1 Pascal second is equal to 1,000 millipascal seconds, and 1 millipascal second is equal to 1 centipoise. Thank you for taking the time to watch this Brookfield video. Please check the Brookfield website for new videos that may be of interest. If you have suggestions for future videos that could be of help, please email your input to sales@brookfieldengineering.com.